We're going to start the day with a few words from Chris, which is always a nice way to start the day. And then we've got Rebekah Tromble in there in the blue dress from Leiden University. And it's really great Rebekah's here. She's really busy. She's running off to Syracuse to live and work for 9 months, practically tomorrow. And she's going to talk to us about web scraping. And she's taken a critical overview because both days we've been very excited about the software we've been using. And it's wonderful. It's great. We haven't really stopped and taken a breath to think about what is it we're actually doing here. What are the limitations of these tools? What is this data we're collecting? And with Rebekah, we'll be reminded that these data, they are people as well. So let's start the day with Chris, and then we'll go straight to Rebekah.
Hi, everyone. I want to take a step back and say, because some of the comments we've gotten is like, wow, this is just too much. It's been overwhelming, and that's all right. I mean, this is a lot to learn, to be honest, in a short period of time. It's really about exposure, getting exposure to this, because it takes a while to learn these kind of things. So at least you're starting from a point where you understand what you need to maybe learn and go back to learning that later. And I've heard that from multiple people before that, this was helpful because I could go back and learn certain things because I didn't know where to start. So that's it's all right if things are blowing up and not working. It's completely fine, it's just all part of the learning process. I think most of you would understand that if you come to a 1 to 3 day event, you're not going to learn, be a complete data scientist in that amount of time. But it's just to understand what our researchers are going through, our community members, to understand how we can think about our services to help them. At the end of the day, we develop services in libraries where it's very structured, and it's like you must do this and that, and then you're experiencing the things that they're doing, and so when they come to you for help, you understand, okay, it's not so structured in their lives, and we have to think about how we make it easier for them, and how we sympathize with them, and I think they appreciate that when you come to them and say, I understand, and let's make this easy for you as well. So the other thing I just wanted to follow up again on GitHub, the power of GitHub. I'm not selling you GitHub, but I think it's a great tool for understanding open research in general. Some of the major concepts that we need to understand as librarians. So one of the things is GitHub is used to run journals now. So the Journal of Open Source Software is a great example of people actually submit, they submit their code and their articles basically through the pull request type of mechanism, and then they do review using GitHub for this content. It's pretty amazing. They get DOIs for this. You can see that they now have DOIs for all this. So it's really interesting idea of hooking into this tool to run a journal. The other thing too is because actually most librarians come from the humanities, so it's good to have these examples from the humanities. In fact, I heard once before that what was it? 60 to 70% of science librarians have humanities backgrounds. So it's an interesting figure. But here's an example of a museum that's using, they posted their data onto GitHub. So like we've heard, using Creative Commons licenses. And they use this mechanism to put their data up here, the collection, so it was more accessible, so it could be reused. And then they've also used this mechanism right here. Again, they're able to cite their work through a repository DOI, Zenodo DOI, using that hook of release from GitHub. So, remember I showed you that citing your code example from GitHub? They've used that for citing their work. And another thing too is I worked with this group. There was a class on data science at Harvard. And what they were doing, and this is the same example that I mentioned to you before, people are using GitHub to run their classes. So the person I worked with who came here last year, Rahul Dave, who taught in DS2-4L, the first one in Copenhagen, he was using GitHub to manage coursework. So students were submitting their coursework in private repos, private repositories, and it was being reviewed through that mechanism as well. And their site is run on GitHub. And that's a really good example, again, to come back to. There were some students yesterday, there was a student that I spoke with yesterday, and as a hiring manager, I told her whenever I go and search, when I have candidates, I go out and search on the web, and I see, what kind of profile they have. Are they tech savvy? And GitHub is indexed by Google very well. You pop up high in the listings, and it looks good. I think it looks good as a savvy, data savvy, a tech savvy librarian to have that kind of profile. And just to follow up to, again, you can post, GitHub renders certain things. So like CSV data, TSV data, these are probably the most portable ways to share data. It renders it so you can actually view it in GitHub and share it that way. So anyways, that's to put things in context for you again, like why you should be learning this, why you should be following it and getting familiar with it. So thank you, and let's move on to our next speaker. Thank you. I didn't close your browser.
Thank you. Is that still on? All right. Yes, you can hear me, correct? Great. Give me just a second to get everything set here. And I realized as I was watching the other speakers that I need to turn off Skype so that it does not interrupt in the middle of my talk today. All right, good morning, everyone. I haven't been here for the last couple of days, but I've been given a fairly good overview of the things that you've been doing. And I'm going to, I think, take a fairly different, alternative perspective. I use big data myself. I'm a political scientist. I do primarily work in media and politics. I'm especially interested in the way that politicians are using social media tools to interact with members of the public. So I'm using these large data sets all of the time myself for my own research. But what I discovered very quickly as I became engaged with social media and big data was that I really didn't have a firm grasp on what the data was. I was using these third-party tools to help collect it. In some cases, I was writing my own scripts in R or in Python to collect this data, but I didn't ultimately have a really firm grasp on what the data was in relation to what was out there. So I started digging into this quite a bit, and I wound up becoming a bit more critical of the type of research that I had started doing and what I see many of my colleagues doing in the social sciences and humanities using social media data broadly. So today I'm going to throw, I think, a bit of cold water on the big data craze, particularly on the what I would say less than skeptical use of social media data to analyze what's happening in the social and political world. I'm going to be focusing on Twitter at the beginning and telling you a lot about the mechanics of Twitter data collection. And when I get to another slide here in a minute, I'll explain why I'm focusing on Twitter. But by the end, the idea is to broaden our perspective and talk about social media data internet data, digital data writ large, and think about the way that the things that I'm discussing in relation to Twitter then apply to our considerations of the data that scholars, that researchers are looking at across digital realms. So just to give you a bit of context, I mean, I've told you already that I came to this because I was interested in really understanding what I was getting my hands on when I started to do some research myself on social media. And this was the project that started it all for me. I have long been interested in what we call public spheres, and I was looking at mass-mediated public spheres, so the way that newspapers and broadcast television, traditional outlets, journalistic outlets, mediate broad public discussions. And I decided that it was time to get my act together and move into the digital realm. And right around the time that I was doing this, we saw the protests in late 2014 in Hong Kong emerge. So sometimes referred to as the Umbrella Revolution or the Umbrella Movement, Occupy Central. This is an image from that movement. From those protests. So we see that these umbrellas were being adopted, right, by the protesters at the time to help fend off the attacks, we might say, from the police who were using pepper spray and other tools against them. And this is how we got to the umbrella, the moniker of the Umbrella Movement or Umbrella Revolution. And the reason that I wanted to study this was because I'm also interested in social movements, social movement activities, and I wanted to apply my questions about public spheres to digital public spheres. So I thought, great, here's this opportunity. I'm going to start collecting lots of Twitter data about what's going on in Hong Kong. I did just that, and I finished, and I realized I didn't know what I was looking at. I really didn't have a sense, if we take this image and we think of it sort of as the universe, right, of tweets, perhaps, that were out there, I had no sense of which of those were actually in my data set. Was I capturing every single one of them? Was I only getting a small handful of them? And if I was getting a small number of them, what was actually leading me to get those and not others? My motivation for undertaking really putting it on myself to begin digging into this, and which will inform my talk for you today, was really twofold. I was interested in, as I've essentially already said, understanding what it is we're actually getting our hands on when we collect digital data. When thinking about this, we need to keep in mind that we're using tools provided by corporate data providers, right? These aren't entities that have researchers, scholars, interests in mind when they're designing their tools, when they're designing their platforms, and when they're designing the tools that we might use to then interface with their platforms. Beyond that, so when I'm talking about the corporate data providers here, I'm talking about the Twitter, the Facebooks, the Instagrams, the companies themselves, right? They are corporate entities with business goals, not with scholarly research goals in mind. And that impacts what the data is that we're actually looking at, but it also impacts how we can access that data in the end. Beyond that, though, we have some concerns that we need to think about, because frequently researchers don't get at the data directly from these platforms themselves. Frequently, we use third-party intermediaries to do the work for us. There are all of these tools that are out there that allow us to get the data through the tools, not from the platform itself. Those third-party intermediaries are then creating, right, inefficiencies or creating gaps, essentially, between the original source and what we're getting, and it's a second layer that we are not privy to, right? We don't have the insider status to understand what it is we're ultimately getting. What this all means in the end, then, is there are naturally biases that are going to be generated in the data that we get from these digital media sources. My second main motivation, my second primary concern, was to fundamentally, critically engage with the ethics of this type of data collection. As Lorna said at the very beginning, data are people. People are data. And when we're working with big data, we frequently forget that, right? We get caught up in the hype. We get excited because look at all these numbers we've got. We've got so many of them. They tell us everything we need to know about everything. This is so exciting. We forget that the numbers are representative of real people in the real world, and the way that we deal with those numbers, the way that we deal with the data themselves, have implications for the people that are involved. So today I'm going to be talking about one way that we have, my colleagues and I have examined the Twitter data that we've been looking at for a couple of years now to better understand how it is that our use of that data over time in particular might affect the data, the people, right, that are behind that data. So first, I want to give you some of the Twitter basics. And in doing so, as I promised just a minute ago, I want to tell you a little bit about why it is I'm actually talking about Twitter, why I'm focusing so much on Twitter. Why Twitter, right? And the reason we need to ask why Twitter in the first place is because Twitter actually isn't the most popular social media platform out there, by a long shot. Facebook and Instagram internationally are much, much, much more popular, are in much higher use than Twitter itself. Moreover, Twitter is far from representative of any given public anywhere in the world. And yet it's often treated as such. Right? Scholars, researchers, journalists frequently react to Twitter as if it is representative of public opinion, and it's not. It's not at all. We can't, right, delude ourselves into thinking this at all. It is not representative of public opinion. But we use Twitter for a few practical reasons and some better, more rooted reasons as well. First of all, somewhere between 96 and 98% of all tweets, of all Twitter data, are public. That means we can actually get our hands on it, right? We can use this data. Not so for Facebook, right, where actually the majority of Facebook data has privacy settings on it. Tweets are public, so we can use the data fairly easily. Second, though Twitter is not representative of publics at large, opinion leaders love Twitter, right? Let's look back at what we've been seeing in the US elections for just the last few months, the last year, I suppose, right? Donald Trump loves Twitter, obviously, but the Hillary Clinton campaign, and we're not just talking in the US, right? Now, I study media and politics, Twitter and politics from a comparative perspective, and what we found is across the Western world, but even now well outside of the West, we're seeing that it's essentially taken for granted that politicians must at least have a Twitter account. Of course, it's not just politicians, it's journalists. And media coverage of Twitter is much higher than any other social media platform, which means that Twitter communication, tweets, can and often are amplified through the mass media. So journalists love Twitter because it's public, right? They love it for the same reason that researchers love it, because they can get their hands on it, and because it looks like somehow it's representative of the public, and because they too can go to business leaders, politicians, look for the things that they're saying, and then use those to produce news, to create stories. So Twitter itself, tweets themselves become news. They get amplified through the mass media, which means that the influence of tweets is totally disproportionate to its actual use among the broader public. So this is why ultimately we're going to focus quite a bit on Twitter today. But again, as I promised at the end, I'm going to give us a more macro scope and think about how the things I'm talking about related to Twitter apply beyond Twitter. So now let's get down to the basics in terms of how we might, and how scholars and researchers often collect Twitter data. Probably the most common way to get at Twitter data is through Twitter's application programming interfaces, the so-called APIs. Twitter has 2 public APIs that literally anyone, anywhere in the world can access. The first API that I've listed here is not one of the 2 public APIs. This is the Firehose. The Firehose theoretically contains 100% of all Twitter content, all the tweets and all of the metadata that are associated with those tweets. The problem with the Firehose is you can only get access to it through third-party partners with Twitter. And the Firehose is really set up for corporate clients, right? For large corporations that want to do evaluations of their customer base. They can get access and they can pay for that access. So though the Firehose is great because it provides real-time access to basically 100% of all content, scholars can almost never afford access to the Firehose. It is ridiculously cost prohibitive. The last estimate that I saw, the numbers aren't actually made public, the last estimate that I saw was somewhere between $3,500 and $4,000 US per month to gain access to the Firehose. So we move on to what are then the 2 public APIs. The first is the streaming API. It is real time, just like the Firehose, but it is a sample of the Firehose. Lots and lots of researchers treat the streaming API as if it's the Firehose. In fact, many don't realize that it is, in fact, giving you a subset of the Firehose. The problem is, Twitter, as a corporate entity, wanting to protect, right, its intellectual property, will tell us absolutely nothing about how those tweets are sampled when they're pushed then through to the streaming API. So what we know is we get some of the tweets. Sometimes it looks like we get close to 100% of the tweets, but we never truly get all 100%. Sometimes we seem to get much less, and we have no idea why. For those like me, in the social sciences in particular, this is incredibly problematic because we don't have a sense, is this a random sample? Is it approximating 100% enough? Is it close enough that we can talk about having, right, essentially the full population of data to work with? But we don't know. The search API, or what is sometimes referred to as the REST API, depending on how you're accessing it, actually provides access to historical Twitter data. So if you're hooked up to the streaming API, you can only get tweets as they come in, and if you miss something, you can't go back and get it through that API. The stream or the REST API actually provides access to historical data, but as I'm going to outline in just a minute, it has very significant limitations. The search API is what the vast majority of scholars use. Right? Those who are in the know recognize now that the search API is problematic. They're moving to the streaming API, but even there, they're not recognizing the problems with it. Still, the vast majority of researchers are getting their data from the search API, and that's primarily because the search API is what most of these third-party providers are interfacing with when they provide the data for us. So for those who aren't programmers, right, who aren't computer scientists skilled at writing the computer scripts, the programming scripts that would allow them direct access to these APIs, they're naturally using third-party providers. And most of those third-party providers use the search API, and they then say essentially nothing to the researcher about what it is you're getting through the search API. So most of us are essentially in the dark. We think, hey, we've got Twitter data, that's great, but we have no idea how we got it or what's actually in there. Another option for getting access to Twitter data is to purchase it through the so-called historical archive. Now, the archive theoretically contains all tweets that have been tweeted since Twitter first began in June of 2006. The problem is it doesn't really contain all tweets. This is another misconception about it. It only contains the tweets that have not subsequently been deleted, which means in practicality, that data decays over time. We lose lots of data. This is something I'm going to talk about quite a bit more in the next few minutes. Another option for getting our hands on Twitter data and really any social media data is to scrape it. Go to the web sites, right, the web interfaces of these social media platforms and actually scrape that data from the web platforms themselves. I'm going to be talking at the very end today about how we might actually use some of these tools to scrape Twitter data. I'll give you some examples. Now I want to go through and give you a few practical examples of some of the services, some of the tools that people might use in order to actually access the data. So let's begin with the third-party services. For access to the fire hose, probably the most used company now for scholars, particularly for social scientists, I think, is Crimson Hexagon. And it's become incredibly popular with social scientists in particular because it's a big name political scientist actually from Harvard who started and runs this company. This gives everyone who purchases access to the service access to the full fire hose. It's much more affordable. The problem is, because of Twitter's terms of service and because you're paying ultimately less than the corporations are being charged for access to the fire hose, you actually get very limited access to the content of the tweets themselves. So you can look at a small sample of the tweets, and if you're interested in the text, right, you can examine the text of those tweets, but then you tell Crimson Hexagon, the company, this is essentially how I would like these tweets to be analyzed. They use machine learning algorithms, apply those to the full set, the full population of tweets that have come through the fire hose, and they do the analysis. But you can't ever go back and get your hands on the tweets that you didn't have access to in the first place. So you essentially have to trust Crimson Hexagon and their algorithms to be doing a good job for you. Now, I'm skeptical not because I think that, right, the scholar running Crimson Hexagon or the company itself is doing anything wrong, but as a social scientist, I am always skeptical when I know that I'm not allowed in practice to go in and dig through the data, right? With big data, of course, I can never look at everything. But if I'm seeing problems that are cropping up in my data, I want to be able to go in and actually look at the content itself. With this type of service, unfortunately, you can't. So a major drawback. A second way to access this data might be through the application Discover Text. This is an application created by another social scientist that's been around for a number of years and has only relatively recently gotten into the business of helping us collect data from social media like Twitter. It's a program that is primarily about doing textual analysis of really any sort of data, whether it's digital data or not. They have access, they're one of the few companies that has access to what's called the power track, which is connected to the fire hose and allows you to do queries on the fire hose. So it too is fairly expensive, but it's not nearly as bad as paying, it's not nearly as expensive as paying for just getting everything dumped on you. Right, so you can do keyword searches and get all of the data coming from the fire hose that matches that. So in theory, this should be 100% of the data that's actually relevant to you as the researcher, to you as the scholar. But because we can't get our hands on the fire hose itself at the same time, we can't know for certain that it really is 100%. Again, we're in trust mode. For the streaming data, probably the most commonly used tool today is what's called TCAT. I should remember off the top of my head what it stands for, because it's my colleagues next door to me at the University of Amsterdam who've created it, but for some reason I can't remember right now exactly what it stands for. But TCAT is a great tool that they built. It's free access. If you have any programming skills, it's very easy to set up on a Linux system. If you don't, it's very easy to get a system administrator who can help set it up for you. You can get access to the streaming API, and actually you can get access to the search and REST API through this tool as well. The search or REST API, as I told you earlier, is the most commonly accessed API, and most of the tools that people use rely on the search API. So Discover Text, which I mentioned above with the Power Track, also collects data for you via the search API. What's interesting is they don't provide any access to data from the streaming API. They've chosen just to go with the search and Power Track. NodeXL is used by tons of scholars, also uses the search API. NCapture for in vivo is frequently used, also the search API. Now, just so we're clear, so you have a firm grasp on this, the search API from Twitter is essentially what gets returned if you're on Twitter's interface and you go up to the corner to the little search box and type something in. Essentially, the results that you would then get from Twitter are what are being pushed through the search API. Okay. Then the next option that we'll talk about simply is the archive, right, which is again where you purchase the historical data. And you can get access to that again through a tool created by Discover Text, which is called Sifter, or from GNIP, which is the biggest official Twitter partner. In fact, Twitter bought it out a couple of years ago. So you can technically get the data effectively directly from Twitter by purchasing it through GNIP, but Sifter is a really intuitive, easy to use interface for getting this data as well. Now I want to talk just a little bit more about the APIs themselves, the nitty-gritty details of these application programming interfaces, and what it is we know about the sort of data that they provide to researchers. For the streaming API, and here I'm talking specifically about when you're collecting data from the streaming API via a keyword query. So let's say I want to get hashtag drain the swamp or hashtag make America great again. Right? I put those as the keyword queries, and there are certain limitations then in terms of what it will return. So it is indeed, via the streaming API, a real-time capture that can capture up to 1% of total global volume. What this means in practice then is there are rate limits to how much Twitter data you can collect at any given moment. Now, it's not 1% of the tweets that are, let's say my query is hashtag make America great again. It's not 1% of the tweets that contain that term. It's up to 100%, in theory, up to 100% of those tweets if the relevant tweets are less than 1% of the global volume of tweets in that moment. So what that means is that if an issue or event that you're querying on is particularly popular, you're likely to hit this rate limit, and the amount of data that you're getting through the stream is drastically reduced. It also means that when my fellow countrymen and women go to sleep or go on vacation or simply out for the weekend, the rate limits are hit much more easily, right? Because Americans are internationally the most voluminous users of Twitter. So when Americans go on break, that means the global volume of tweets goes down. And if you're following an event in another country that is particularly interesting, or even in the US, right, is creating a lot of attention, but most Americans are in bed or on holiday, then it means you're very likely to hit those rate limits. Twitter will tell you when you've hit the rate limit, right? It sends you a little bit of data information to say you've hit the rate limit, but you have no idea then how much data you're actually capturing in relation to what you could capture, what the full population of that data is. The search or REST API, again, I'm talking about using this in terms of doing a keyword query, right? There are different parameters depending on how you're actually querying Twitter data. But if you're trying to do a historical capture by keyword in particular, username you could use as well, but by keyword I'm considering here in particular, there are very significant limitations. So, while you can get data for somewhere between the last 7 to 10 days, and again, it depends. Every single time you put a query in, maybe you're going to get the last 7 days, maybe you're going to get all the way to 10, you never know. But somewhere to the last 7-day period, you can actually only capture up to 18,000 tweets for that 7 to 10-day period, whichever limit is reached first. So if there are 20,000 tweets that have been tweeted in the last 7 to 10 days that match your query parameters, you can at most get 18,000 of them. What my research has shown is that you actually, even if there are less than 18,000, you get far less than the 18,000 in that 7 to 10 day period. You can only issue a call, issue a query, 180 times within 15 minutes. So those using the third-party services or writing your own script to interface with this, you have to time those calls very carefully in order to maximize the amount of data that you can get in a 15-minute period. And most importantly, the search REST API results in capturing far less than 100% of the tweets. Twitter has actually released a couple of blog posts to very helpfully give researchers a bit more information about what's coming through the search API. Right? This is what they've told us when they've written these blog posts. We're doing this for you. What they tell us is they're giving us top tweets. That's it. Top tweets. How are those defined? We have no idea. Again, it's proprietary. You know, this is something that, as a social scientist, frustrates me to no end. I've actually had a meeting with representatives of Twitter to try and convince them how difficult this makes our lives. Unfortunately, it's a non-starter. Right? The fact that we just have no idea what we're getting our hands on through the APIs has to be a fact of life from their perspective. For the Firehose API, I've actually talked about most of these drawbacks. Again, it's only accessible through an official Twitter partner, is incredibly cost prohibitive, is designed for corporate use, does not have academics in mind in any way, shape, or form. And as I said with Crimson Hexagon, some of these services won't actually let you see all of the tweets, the content of the tweets themselves that theoretically you've purchased. And then we end with the archive, which I want to be really clear is not an API. It's not an application programming interface. It's a database that you can query and retrieve the historical tweets from. And as I said before, it's not actually a record of all tweets. It's all tweets that have not been deleted or removed for one reason or another. Now, mind you, tweets can be deleted for any number of reasons. It may be that the user has decided, right, I want to get rid of this content. It's embarrassing. I don't want it there anymore. It might be that the user has simply shut down his or her account. If that's the case, as soon as the account goes dormant, all those tweets are removed from the archive. It may be that Twitter has shut down an account or removed tweets for abuse. It may also be actually that the user chooses to move their privacy settings. So rather than tweeting publicly, they've decided to change their account to private. All of their historical data then goes private and disappears from the archive. So you can't purchase that data at that point anymore. One last thing that's really important to know about the Twitter archive data is that Twitter's terms of service actually require those using Twitter data, capturing, purchasing, collecting Twitter data, to go back and remove from our own data sets the data that has subsequently been deleted. So if we've collected data from a year ago and 5% of the users have removed their tweets from the public domain, we are actually required to keep track of that and remove those tweets from our own data set. Do you think anybody does it? No. Not even close. Nobody's paying attention to this because for academics in particular, the infrastructure to try and monitor and keep up with this is, it's almost inconceivable. Corporations, right, that are bound by Twitter's terms of service are themselves struggling to do just this. There is one special arrangement that Twitter maintains with a nonprofit organization called Paul It Whoops, which it's Paul It Whoops in the American context, but it also has affiliations with organizations in the UK and in the Netherlands. And these organizations collect all tweets from politicians in these countries, and if politicians delete their content, these companies then automatically retweet the content. So it's actually part of this project created by the Sunlight Foundation, and the idea is to keep politicians accountable. If they're trying to get rid of their embarrassing stuff, we actually should be able to look at it. And Twitter has, after some kind of back and forth ugliness for a while with this organization, Twitter has agreed to allow them to continue these practices. But for everyone else, we are supposed to be getting rid of our Twitter data. Now I'm going to move into the ways that myself and two of my colleagues, Danny Stockman, also from Leiden University, and Andreas Storz from the University of Amsterdam, the three of us have been working with a number of different Twitter data sets to try and investigate the things that I told you at the very beginning were my main motivations, right? What is it we're actually getting our hands on? And what are the ethical implications of using this type of data? So I'm going to begin now by showing you one of our most recent projects where we have used data from November 8th's US elections. We collected data over a 48-hour period on the 8th and 9th of November, so just a month ago. And we used a keyword query for any tweets that were essentially mentioning Governor Gary Johnson, Dr. Jill Stein, or Evan McMullin. So for those who haven't followed the third-party candidates in the US very closely, these are the main three. Now, you note, and you might think to yourself, well, wouldn't it have been more interesting to capture tweets that were referencing the main candidates, real Donald Trump or Hillary Clinton? Yes, it absolutely would have been, but we knew for certain, right, we knew we were absolutely guaranteed to hit that 1% global rate limit for the streaming API if we were using those query terms. We just knew on election day there were going to be so many tweets with real Donald Trump and or Hillary Clinton in them that we would not get 100% of the potential from the streaming API, which was what we wanted to do. So we instead used this keyword query, which we knew would have a much lower volume, but still quite interesting and obviously relevant to the activities of the day. We captured data from the Discover Text Power Track, which I mentioned a few minutes ago. So real-time data, keyword query from the fire hose. During this 48-hour period, it returned 226,118 tweets. Again, we cannot be totally certain that this is 100% of all tweets that meet our query parameters, but Twitter claims it is or should be. Now, of course, even if we were connected to the fire hose and getting the entire dump of all tweets, infrastructural capacity, infrastructural issues could mean that, and these could be infrastructural issues on Twitter's end or on our own end, right, would almost certainly mean that we're not going to truly get all data, every single tweet. But by querying the fire hose, using the power track, we believe we're being told that we should have essentially everything. Our second means of collecting data was through the streaming API, through a script that myself and Andreas wrote for Python. Again, collecting the data in real time. We did, by using this keyword query, ensure that we didn't have any rate limits, and indeed there were none. So this returned 185,490 tweets, or 82% of the power track tweets. Again, not 100%. And scholars, researchers are proceeding frequently as if they're definitely getting 100% using this API. Then using the search API, which we accessed again through a Python script that we wrote, we did the maximum number of calls that we possibly could from the 8th of November through the 17th of November. So trying to maximize, because again, you can go back 7 to 10 days, trying to maximize the number of relevant tweets that we could get in that period. And in this case, we collected almost 113,000 tweets, or just under 50% of the tweets that were available through the Firehose power track. So what we see from the very beginning is, if we're using the normal means, quote unquote normal means of access to Twitter data, we're not getting near the full data available. So our first research question using this data was, what bias or biases are introduced using the different APIs? So we took all of these tweets, and very frantically in the last few weeks, we've been writing scripts to extract all of the @ mentions, so the @ username found within a tweet, and all of the usernames, meaning those who are actually sending the tweets. And we produced lists of top 10, 25, 50, 100, and so on. So the top number of users who were mentioned in the body of a tweet, the top 10 users who actually tweeted, right? So we produced these top lists across each of the API data sets. And then we compared them using a simple metric, Kendall's tau, which looks for correlations across ranked lists. So if I have a list that has let's say our users are 1, 2, 3, 4, and 5, and they are in, right, the top most frequently mentioned user is 1, right, and they move in that order, let's say that data set is hypothetically coming out of our power track data. Then we take the data from the stream and ask, are those users showing up in the same order, right, in our ranked list, and calculating correlations across those data sets in that way. Here's what we found. Using the mentions data, we found comparing, the power track is always the baseline in these calculations, naturally, because this is what we believe to be the full population. What we found was that we never get higher using the streaming data, comparing the power track to the streaming data, we never get higher than about 85% correlation, 0.85. The search is utterly abysmal, right? Now, the reason that we're thinking about these top 10, top 25, top ranked lists is because frequently, when we're doing analysis as researchers of social media data, we want to dig into the data and further explore, right, who are these people who are acting as the most prominent actors in here? What are the most common hashtags, and what are they telling us, right? What's the story that these most frequently used mentions, most frequently used hashtags are telling us about what's actually going on in the Twitterverse. But if we're using data that are misrepresenting who those actual top users are, then we're telling the wrong story, ultimately. And what myself and my colleagues were looking for, were hoping for, particularly with the streaming data, is that we'd have correlations that were at least approaching 0.95, right? Because anything below a sort of 5% level we can think of as probably just, not necessarily, but effectively just noise, not likely to do a lot of damage to our analysis. But as soon as we start inching above, right, the 5% level, that's a mismatch, then we know we're getting into dangerous territory. And even with the streaming data for those mentions, right, the best we do is 0.8467, 0.85. With the search data, my gosh, that first number, right, is particularly bad, the 0.244. There, we never get above the 0.61. With the usernames data, the story is much the same, although in the top 100 list for the stream, we do get to the 0.9 level, which some might argue, right, could make the data usable, but it still didn't reach the standard that we had set from the outset. And while the search data starts to do a bit better, it's still not great overall. So then we moved on to our second research question, which is, okay, we now know that we're not getting the full data. We know that there are likely biases being introduced by using these different means of data collection. So can we sort of reverse engineer things, because Twitter won't give us access to their APIs? Can we kind of reverse engineer things to understand why it is that some tweet is actually pushed through to us via one of these APIs? So what factors seem to drive the API samples that we're getting? So in this case, we did a ton of logistic regression models where the dependent variable was, did it appear or not? So we took all of the tweets from the power track, right? And then we simply coded a 1 or a 0 if it appeared in for a model for the stream. If that tweet actually appeared in the stream, it gets a 1. If it doesn't, it gets a 0. And then we took two broad sets of independent variables or predictor variables to try and understand what were the factors that Twitter seemed to be using to push data to us. And the first set of those variables were the user characteristic variables. So just to, be perfectly honest about all of this, this is straightforward data mining that we're doing here, right? There's no theoretical grounding that we have for any of this analysis. We're essentially trying to put ourselves in Twitter's mind, so to speak, and ask ourselves, what are some of the priorities that Twitter might logically set for prioritizing tweets that members of the public get access to? So one of those considerations might be whether the user, right, who's tweeting something is particularly prolific. So if they're high volume users, it may be that Twitter wants to prioritize their content. It might be that if the Twitter user is particularly popular, right, has millions upon millions of followers, that they get priority. It might also be that Twitter is prioritizing how engaged a user is. So do they have lots of people who they follow, right? Not that are following them, but they actually follow. All of these are ways to naturally demonstrate that you are of the Twitter community. So it may be that Twitter is then prioritizing tweets from these actors. Second, we looked at the characteristics of the tweets themselves. The first being what we called originality, which is simply, is it an original tweet, one that the person has produced themselves, or is it merely a retweet of someone else's content? Second, Is there a form of engagement with others? So does the body of the tweet itself contain an @mention of other users? Third, are they engaging in a form of public discourse by using hashtags? And finally, is the content itself particularly rich in the sense that it doesn't just have a tweet text, but attaches some form of multimedia to it? A video, a picture, these are the most common forms. Okay, so we ran a bunch of different models. I won't get into the nitty-gritty, boring details, all of it. Just know that we introduced variables in a stepwise fashion with all sorts of interaction effects. And what we ultimately found was that the simplest models without any interaction effects prove best. So that's what I'm going to show you now. This is the very first regression result for the search API, right, compared to the power track data. A lot of stuff going on in here, and I'm now realizing that my pointer doesn't work on this screen, so I've been pointing a lot completely fruitlessly. But when we're using these high volumes of data, we sort of naturally expect to find statistical significance most anywhere, so we're not really looking at that. We're most interested in these odds ratios, which are giving us a sense of the effect size. And if you haven't worked with odds ratios before, they're fairly simple to understand. The closer the value is to 1, the less difference there actually is, or the less effect is actually being produced. So we're most interested in the data that are furthest away from 1 in our odds ratios value. And I'll highlight those in just a second. Right, we see similar sort of results for our streaming data. Basically, statistical significance is showing up with most everything. We've got our odds ratios again. I'll now highlight the odds ratios for you to consider more carefully. That is, for the search API, it's primarily focused on the content of the tweets. Not the people, not the users who are tweeting, but the actual content of the tweets. So a tweet is more likely to appear if it's an original tweet, less likely to appear if it's a retweet. It's more likely to appear, actually, the fewer mentions that it has in it, which surprised us. I'll talk about that just a little bit more in a minute. More likely to appear the more hashtags it contains. Roughly the same thing for the streaming API, with the additional exception that adding multimedia to your tweets, if you want to, right, get your own content out there, it seems the best way is to make sure that you have content-rich materials. So add pictures, add videos, put lots of hashtags in there, and create your own content, right? Don't just retweet others. Now, for the mentions count, I was completely surprised when I saw that this is a negative relationship. I expected, my hypothesis, working hypothesis, was that the more people you mentioned, the more active and engaged it showed you were, so that was likely to get your tweet pushed or promoted by Twitter. But this turned out not to be the case. We've been running all of these numbers sort of frantically over the last few weeks, so these models aren't done yet. What I can tell you I suspect is happening with this mention data is that Twitter is not prioritizing replies to tweets. So a reply happens when, right, you hit the reply button to directly respond to someone else's message. And when you do so, their @username goes to the very front of the tweet. I strongly suspect that Twitter is saying it's less important for the public, journalists, corporations, whomever, to look at these sort of conversations that are happening than the original content. We need to test that. I haven't done it yet. But otherwise, what we see is, in general, it's the content of the tweets and not the user characteristics that leads to priority. So our tentative conclusions then are, as I just said, content seems to matter. The user, much to my surprise, does not seem to matter that much. So if you're really popular, It doesn't seem that being really popular makes you more likely to get your tweet out there through Twitter's API mechanisms. And we're looking at especially rich content here, which ultimately has pretty clear implications for pretty clear consequences for any interpretation that researchers might want to do. We're not looking at a random sample, right, of Twitter content when we deal with this data. The rich content gets through more than anything else. I think that this is probably a good time for a bit of a break. I think I need a little bit of a break. So before I move on to my next set of questions, which are really informed by, I show you the first question here is how does digital data decay over time? But it's actually more fundamentally about the ethical implications of how we use this sort of data. So we'll take a bit of a break here and then return.
We can take a few questions.
Yeah, if we want to do questions,
and then
that's
a break.
totally fine with me. Please.
Yeah, and if anyone has a question, because I do.
And I'm sorry, I should have said from the very beginning that interrupt me at any moment in time and ask questions about any of this.
It's more. It starts off as a comment and then into a question. But as librarians, we often get this question like, where can I find this kind of data, right? Like a lot of people are interested in sort of mining this data and using it in their research. So we kind of list off a bunch of tools. This is really helpful for understanding. I mean, I think I long suspected that don't trust the data in general. I think that's a common theme throughout life in general. Don't trust anything. But so, what would your recommendations be when we're talking to researchers then?
Well, so that's something that I'll talk more extensively about later after I kind of get through presenting, what our findings show us in practical terms about how good or bad the data are. But what I can say, right, from the very beginning is that if people have the resources, right, to purchase the data, especially from the Power Track, to some degree, also it might be beneficial to purchase it from the archive, that's the way to go. Because we simply can't know, even though we're now doing this reverse engineering to try and get a sense of, what the characteristics are of the data that we get our hands on, we can't guarantee, right, that those results are accurate for anything more than the data that we have looked at in this moment. If for no other reason than because Twitter, right, these corporations in general are constantly changing their own APIs. They're literally on a minute-by-minute basis changing the APIs, usually just in minor ways that probably aren't having gigantic effects on the data that we're looking at. But sometimes there are larger changes. Especially, Twitter did a massive overhaul of the search API about a year ago. So because of that, it's probably best to try and recommend that if they can afford it, right, researchers should get their hands on the full population as much as possible, using the Power Track, using the archive. If they can't, the second best option that I found is actually scraping the data with some limitations, and that's what I'm going to talk about much more extensively at the end.
Yeah, just a couple of quick questions, because my background is in natural sciences, so I have a completely different view of what data is or are. But is this data reproducible? And what sort of, I think about what sort of, and I'm not familiar with humanities at all or the review process, but if you have this data down from Twitter, what sort of comments do you get from reviewers when you're going to publish this? I mean, it just seems to me very vague.
Yep.
But again, I'm a biologist, not a sociologist. So.
Well, so as a social scientist, we like to, pretend that we're doing science as great as the natural scientists do, and we ask ourselves all of these questions about reproducibility, right? To try to hold ourselves to these standards. But the truth is that digital data, the way we collect digital data, and what we can then do with those data really prohibits us from getting nearly as close as we would like. So when I start addressing this third research question, one of the things that lies at the heart of the concern over data decaying over time is a question of reproducibility. Beyond that, right, Twitter specifically, Twitter explicitly prohibits researchers from sharing their data with one another. And that includes even outside reviewers. So if we are submitting articles for review to a journal that requires data checks, that requires a replicability check, technically, if you're using Twitter data, you are not allowed to submit to those sorts of checks. There are things that researchers can do. So Twitter does allow you to provide a list of all the tweet IDs that are in your data set. But the problem is, as I'm about to talk about, if the data are decaying over time and we try to then go recollect all of those same tweets, a number of them are going to be missing. So replicability is very clearly, and reproducibility are very clearly damaged as a part of this process. And just overall transparency, right? When we're working with corporate entities that put limits on how we can use their data, then it has very significant implications for the transparency of our processes. It's a major concern.